Okay, so we're going to start with our exponent rules. These are kind of a review of what you've learned in Algebra 1, but we'll take it kind of fresh, like, we don't remember it from Algebra 1. So we're going to start off with an example 1. Example 1 has a squared, and you'll notice a squared is a times a, and then they have a cubed, which is a times a times a. Right here, between the two of these, you'll notice you are multiplying 5 a's. Well, that first rule is if you are multiplying like bases and our like base is a, then you add the exponents. In other words, we could do 2 plus 3. So we get a to the 5th. So you notice you could write it out, or you could just add your exponents to figure out what the simplified version would be. Please keeping in mind that some of these are going to get lengthy, so writing it out is not the option. We need to go with using the rule of a to the b times a to the c. When multiplying like bases, we add the exponents, okay? So then we have our practice problem here, a. It's y to the 7th times y to the 5th. When I am multiplying like bases, I would add the exponents, which means I would end up with y to the 12th. The next rule we're going to look at is when we raise a power to a power. This is a squared being cubed. In other words, a squared times a squared times a squared, which means I'm now multiplying 6 a's, right? Well, when you raise a power to a power, you're going to actually multiply the powers. So I end up with a to the 6th. So once again, our rule for this, if I have a to the b raised to the c, that would be a b times c. When you take a power and raise it to a power, multiply your powers. So here we have y to the 8th raised to the 5th power. That means y to the 8th times 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 y to the 8th. Okay, so we could write that out, and all this would end up doing is being a whole bunch more work. Well, these are multiplying like bases, so it'd be 8 plus 8 plus 8 plus 8 plus 8, whoops, plus 8, or we simply can power to a power, multiply your exponents, which will give us y to the 40th. Oops. 8 times 5 equals y to the 40th. Okay? Our next scenario will be when we're dividing like bases. Here it's written out, a to the 7th, you have 7 a's, a cubed, you have 3 a's. Keeping in mind, these could cancel. When they cancel, they become 1, because a divided by a is 1. They do not become 0. So then you're left with a times a times a times a, which is a to the 4th. When dividing like bases, you subtract the exponents. So what you may have noticed is that 7 minus 3 is a to the 4th. Okay? So when dividing like bases, our like base is a, we would subtract our exponents b minus c. Okay, now there's a way I do dividing to keep it a little simpler so you don't end up with negative exponents. And we'll go more into detail with negative exponents, but I'm going to walk you through on these right here. I asked the question, where's the bigger x? X to the 6th or x to the 5th? Well, x to the 6th. So it's on top, so write it on the top, and then just simply subtract 6 minus 5, which leaves you with 1. I don't have to put the 1. Where's the bigger y? It's also on top. 10 minus 7, so that would be 3. And what this does is it prevents you from having to deal with negative exponents. And once again, we'll get into that into a minute. In this case, I'm going to deal with my coefficients first. 12 22nds, they're both divisible by 2. So 12 divided by 2 is 6. 22 divided by 2 is 11. Next thing I would ask is where's the bigger m? It's on top, so I'm going to write it on top. And then I'm going to take 3 minus 1, which will give me 2. Where's the bigger n? It's on top, and I'm going to take 8 minus 2, which is 6. Okay, so let's see. So far we've got when multiplying like bases, we add the exponents. If you have a power to a power, you multiply the powers. And if you're dividing, you subtract. So now let's talk about what happens here. This would equal 1, this would equal 1, and this would equal 1. 1 times 1 times 1 is 1. If you did it the other way, when dividing like bases, you subtract, you'd get a to the 0. Well, we already know it equals 1. And the rule is anything raised to the 0 power equals 1. That's like the easiest problem you're going to get. I encourage you to test that out. Plug 5,000 to the 0 power in your calculator. The answer is 1. Okay, so this is that scenario where I was talking to you about negative exponents. So I'm going to do the way I was telling you to do over here on this side. I would ask you where's the bigger A, and you would say it's on the bottom, and then I'd tell you to subtract 5 minus 3, and you get 2. Since there's nothing on top, you just put a 1 there. Okay? Notice I don't get a negative exponent. Here's the same thing. These are all going to cancel, giving you 1, and you end up with 1 over A squared. Okay? If you did it when dividing like bases, you subtract them, you're going to get A to the negative 2. A negative exponent simply means if it's upstairs, move it downstairs, and the negative goes away. Likewise, if it's downstairs, move it upstairs, and the negative goes away. So, for example, the rule is a negative exponent will just move it to the other spot. If it's in the numerator, it'll move to the denominator. If it's in the denominator, it'll move to the numerator. So in this case, I can make this a positive exponent by moving it to the denominator. Please notice, the value of your base, A, will never become negative. The negative exponent simply moves it to the other place, the numerator or the denominator. So x to the negative 7th is 1 over x to the positive 7. If you want to make the negative exponent go away, just move it. P to the negative 11 goes into the denominator as p to the 11. R to the negative 3 goes into the denominator. And both of those exponents now are positive. Q to the 9th just stays on top. Okay? So that's how you make a negative exponent go away. So then an exponent goes with what immediately precedes it. Always. It does not go with everything in front of it, just what is exactly in front of it. Okay? So in this case, we have a over b raised to the 3rd power because of the parentheses. Because of the parentheses, both the a is being cubed and the b is being cubed. So we would have a cubed over b cubed. Same thing here, except keep in mind here we have a power to a power. So that would be a to the 6th, but then b is being cubed. That 2 only goes with the a. It is not in any way associated with the b. So an exponent goes with everything that precedes it. So if there are parentheses precedes it, everything in the parentheses will be impacted by that exponent. So here I have a power to a power, so it would be 4 times 6, which is 24. A power to a power, so 5 times 6 is 30. Because both of those are being raised to the 6th power. Once again, the same idea. We've got everything within the parentheses will be impacted by this, which means the a is going to be cubed, and the b is going to be cubed. So the rule is ab to the n would be a to the n, b to the n. That is totally different than if I had ab to the n. The only thing being raised to that nth power is the b in this case. The a has nothing to do with it. Okay, so this is a common mistake. The 2 often ends up being left as a 2, but this is also 2 to the 5th power. X squared to the 5th power would become x to the 10th. Y cubed to the 5th power would become y to the 15th. And then we could simplify this. 2 to the 5th power is 32. X to the 10th, y to the 15th. So you'll notice that 2 will not remain a 2. It is also being raised. The only way it would remain is if it looked like this. Now that 5th power is only impacting what's in the parentheses, and the 2 would not be part of it. Okay, so here we've got this negative scenario again. Keep in mind it impacts everything in the inside. So in other words, we have a to the negative 3 over b to the negative 3. Well, if I want to make those negatives go away, I simply take the b and I put it on the top, and I take the a and I put it on the bottom. Another way to deal with this would be to immediately deal with the negative. You can take the negative and take the inside and just flip it over like they did here. So, to make the negative disappear, a over b could become b over a. Now I have a positive n, and then, of course, my exponent will go to everything in the parentheses. Next scenario, to make my negative go away, I got 3z to the 5th would go to the top, x cubed would go to the bottom. And now it's just raised to the positive 2. I've made the negative go away. Now I have to square everything in the parentheses. So 3 squared is 9. Z to the 5th squared would be power to a power, so you multiply them. X cubed squared, power to a power, so you multiply them. Okay? If you have any questions, let me know.